date is Tuesday, October 6th. And even though we talked about this one in class, it got kind of messy towards the end. And so I wanted to redo number 3 from the merit worksheet, which wants us to find the extreme values of a function f subject to the constraint g. And this is not really the kind of constraint we're used to. Normally we would want it to see g is equal to exactly something. This constraint is actually defining a region. I've got x squared plus y squared is less than or equal to 18. So that's like the circle of radius square root 18, and then everything that's inside that as well defines our region. And this region is closed. I know it's closed because of the less than or equal to sign, that because it allows for the possibility of being equal to, that means I could be right on the edge, right on the boundary. Or by looking at it, I can see that, yeah, I do want to include all those points that are boundary points. I want to include the points that are on the outer rim of the circle. So this is definitely closed. It is also bounded. And it's bounded because either I look at the equation and I say, okay, I can't take x or y off to plus or minus infinity because then x squared plus y squared would be greater than 18. So either by looking at the equation or by saying, you know what, I can draw a slightly bigger circle around this region and contain the whole thing. So that means it must be bounded as well. And then finally, I'm looking at the function f, which is very well behaved. There's no square roots, no logarithms, nothing in the denominator. So it is continuous everywhere, and in particular, it's continuous on this region. So I've got a closed and bounded region, and f is continuous on it. And that means I can apply the EVT, the extreme value theorem. And what that is telling me is that f has extreme values on the region x squared plus y squared is less than 18, either one where f sub x equal where f sub x equals f sub y equals 0, where both of my partials are equal to 0, or 2 on the boundary of the region, which is given by x squared plus y squared is equal to 18. So EVT is not telling me what is the extreme value. It is not telling me that these will necessarily give me which of these is the extreme value. I just know that the extreme value is going to occur either under number 1, where the partials are both equal to 0, or under number 2, where I'm on the boundary. So I do have to consider both cases. Let's start here. F sub x is equal to 2x plus 4. And if I want that to be equal to 0, then 2x should be equal to negative 4. So x should be equal to negative 2. And if I want fy to be equal to 0, fy is equal to 2y minus 4. Add 4 to both sides to get 2y equals 4, and then divide to get y is equal to 2. So what I'm concluding here is that if x is equal to negative 2 and y is equal to 2, then the partials are both 0. So negative 2, 2 could give an extreme value for f. I'm not saying it is an extreme value. I'm not saying if it would be a max or a min. I'm just saying could be an extreme value for f. And now I want to do the same thing with the other possibility, which is that I'm on the boundary. Now, if I'm on the boundary, then I can take this as my constraint and then just use Lagrange multipliers. So then I would have the gradient of f is equal to lambda times the gradient of g, where the gradient of f we've already calculated in finding those partials from the part 1, the first method, as 2x plus 4, 2y minus 4, and then that should be equal to lambda times the gradient of x squared plus y squared, which should be just 2x, 2y. So that's telling me 2x plus 4 should be equal to lambda times 2x, and 2y minus 4 should be equal to lambda times 2y. Now I did this in class and I'm going to do it again. I'm going to just divide everything by 2 because everything is divisible by 2. That'll give me x plus 2 equals lambda x, and y minus 2 equals lambda y. And now I'm going to divide both sides over here by x to get lambda equals x plus 2 over x. Here I'm going to divide both sides by y to get lambda is equal to y minus 2 over y. And now if lambda is equal to both of these, then both of these must be equal to each other. So I'm going to set x plus 2 over x equal to y minus 2 over y. Cross multiply to get yx plus 2y is equal to yx minus 2x. I'm going to subtract off this copy of yx that's on both sides to get 2y equals minus 2x, and divide by 2 to get y is equal to negative x. So if I'm on the boundary and I'm at an extreme point, it must be the case that y is equal to negative x. Now I'm going to take that and plug back into the equation that my constraint was giving me, which is that x squared plus y squared equals 18. And I'm going to plug in y is equal to negative x so I can solve that to get a numerical value. So x squared plus y squared is now equal to x squared plus negative x squared. But negative x squared just squares to the same thing as x squared. So this becomes x squared plus x squared is 18. So 2x squared is 18. Divide both sides by 2 to get x squared equals 9, and then take the square root to get x should be plus or minus 3. And I had from here that y should always be negative x. So if x is positive 3, y should be negative 3. If x is negative 3, y should be positive 3. So what this is telling me is negative 3, 3, and 3, negative 3 could be extreme values for f. So at this point, I have 3 points, negative 2, 2, negative 3, 3, and 3, negative 3. And those are the only possibilities for extreme values for f subject to the constraint g. That's what the extreme value theorem tells me. So then to figure out what my absolute extreme value is, what my absolute max and my absolute min are, I'm going to plug in these 3 points. And the biggest of all 3 must be my absolute max. The smallest of all 3 must be my absolute min. So I'm going to find f of negative 2, 2, which is negative 2 squared is 4, plus 2 squared is 4 plus 4 is 8, plus 4 times negative 2 is going to be minus 8, minus 4 times 2 is going to be negative 8. Now let me plug in negative 3, 3. That's going to give me 9 plus 9 minus 12 minus 12, which is negative 6. And f of 3, negative 3 is going to give me 9 plus 9 plus 12 plus 12. So that's going to give me 42. And I'm going to conclude that this is the 42 is the absolute max. Negative 8 was the absolute min. And this is fine. It's okay that I didn't end up using negative 6 because all that EVT was promising me was that that could have been an extreme value. It turns out that in this case, one of the extreme values happens along the boundary, and the other extreme value happens inside the region at a point where fx equals fy equals 0. I think that's all I want to say about this problem, but as usual, if you have any questions, feel free to email me or ask about them next class.